Welcome you back to our YouTube channel. We'll continue from where we stopped. So I was saying that compound A was given as a straight hydrocarbon. It is made up of two elements. See, we don't have a branch in it. Yeah. All atoms are arranged in a straight line. So hydrocarbon means that this compound is constituted by two elements, hydrogen and carbon. There's nothing else. It is constituted by hydrogen and carbon. So compound A has two atoms. It has two atoms which are hydrogen and the carbon as highlighted there. And if it is a there are two hydrocarbons that there are two not two, sorry. There are three hydrocarbons. Twin alkanes, twin alkanes, twin alkenes, twin alkynes. Those are the three forms of hydrocarbons we are going to interact with. However, with the time we shall see that there are others. Yeah, but I'm going slowly by slowly because we haven't covered a lot. Been always saying this. So at this point in time, there are three hydrocarbons we know: tumanya alkanes, alkenes, and alkynes. Then also, this hydrocarbon has six carbon atoms. It has six carbon atoms, and it has six carbon atoms, and a molecular mass of 86. It is there. It was provided. Six carbon atoms and molecular mass of 86. Be about what day. However, if I know that this compound has six carbon atoms, remember it is made up of carbon and hydrogen. I must also know how many hydrogens does it have. How many hydrogens does it have? So we're concluding very well on how it is constituted. So if I know that a hydrocarbon can be an alkane, you see, an alkane for an alkane use this to generate them. I hope you can see. For alkanes, we use this formula in blue. For alkenes, we also use that formula in blue. Alkynes, we also use that. Now, in this case, I have a compound of this form. Why am I saying that it is of this form? It has six carbon atoms. It has anion hydrogen. So I put HY. So if I know that it is a compound of this form, I just equate this to 86 and obtain the value of Y. Then if I obtain the value of Y, then I can progress. Therefore, for compound A, this is what we are going to have. For compound, we are having compound A. Compound A, where are you? So this is what we are having. We have C6Hy is equal to 86. C6Hy is equal to 86, provided maybe on the front page of the examination paper. This information is always put in there on the front page of the examination. Information which is always provided. C is 12, C is 12, and the H is 1. So if C is 12 and the H is 1, if C is 12 and the H is 1, colleagues, if C is 12 and H is 1, so I'll have atoms, then plus 1 times Y, because I have Y hydrogen atoms, and I equate this to 86, colleagues. I'll solve for value of Y. 12 times 6, that gives 72 plus Y equals 86. Then making Y the subject, have Y equals 86 minus 72. Yeah. If I take this 72 the other side and I make gives 14. So it means that my compound now is C6. My compound now is C6H14. You see, C6H14. Now I have to identify, is this analkane or analkyne? Remember, for alkanes, the formula is CN H 2N plus 2. This is for alkanes. Now I know the value of N. The value of N is 6. If I substitute 6, then I'll have, where I have N in this formula, I'll have, if I substitute 6, I'll have C6 H 2 times C2. So this gives C6. C6. What is 2 times 6? That is 12. 12 plus 2, 14. So this is C6H14, meaning that this compound is an alkane. And if it is an alkane of this form, you know how we call that? Ekyo molecular formula. We don't work with molecular formula. Maybe if they are specified, work with that, but we always work with structural formula. I have to draw the structure formula of this. First of all, they told me that it is a straight chain hydrocarbon, straight chain hydrocarbon. So straight chain, not no, it's not branch. So I have those are three. Those five, six. So those are my by four bonds.